Okay, so today we'll be covering some binary codes that you should know. We covered BCD in detail last video, and I'd recommend watching it now if you haven't already. Today we'll be showing some other ways to represent decimal, as well as showing how computers read and write text. Let's get into it. Firstly, we'll see some codes that can be used to represent decimal. There's weighted codes like BCD, as well as some unique ones listed here. Each bit position in the code will represent a value. For example, the number 1000 has a 1 in the furthermost left bit position, which is 8 in BCD and 2 in 2421. There's also unweighted code like XS3, which is just BCD with 3 added to it. Take note of the example here. Now we'll cover gray code. It's used mainly when an analog signal is converted to digital. Only one bit changes between values. Let's look at this example from 7 to 8. In binary and BCD it changes all 4 bits. Whereas in gray code it only changes 1 bit. You can find a table for gray code online. Now we'll see how computers write text. Well, it uses ASCII, a 7-bit code. It can represent 94 printable things, as well as 34 non-printable things. There's 3 types of non-printable things: format effectors, info separators, and communication control characters. You can find an ASCII table online. Now we'll see how we detect errors in ASCII. Well, the 8th bit is free as ASCII only uses 7 bits. This bit will be used to make the number of ones in the code either odd or even. Let's use the example letter A. In even parity, the number of ones needs to be even. So the extra bit will be 0. Whereas in odd parity it will be 1. How does this detect errors? Well, if the number of ones in a code is even when it's meant to be odd, or vice versa, it means at least 1 bit has changed. Unfortunately, this only detects if an odd number of bits has changed, so additional measures are put into place. What happens after an error is detected depends on the application. One thing they could do is send an ASCII NAC. This is one of the control characters in the ASCII table and lets the other end know there was an error. That's it for today. Thanks very much for watching. In the next video, we'll do some problems using binary codes like ASCII. Like and subscribe for more computer science content.